Hi, I'm Christopher Lewis Saint, and this is my video for EEE 120 Lab number 1. This is my design for a full adder, which functions where the sum is 0 when both A, B, and C are all different values, and the count is. So the purpose of this circuit is to add 3 1-bit numbers. Testing some values A plus B with the equivalent of 1 plus 1 plus 0, you get 1 0. The 1 0, which is 2. The count is in the 2's place and the sum is in the 1's place. If you add A plus C in, meaning 1 plus 0 plus 1, you also get the same result. And the same with 0 plus 1 plus 1. But if you get 1 plus 1 plus 1, you get 1 1, which is 3. And this is also proven with the GTK way for the full adder, which shows that the only way the sum and the only time the sum and the C out, the carry out, are both 1 is when all 3 are 1s, and it shows the exact same behavior as talked about in the full adder. Now switching to the incrementer. Which basically, with the function of this is it takes in a number and add 1 to it, to y. And the y represents, and the carry represents the extra carry bit. So let's, for example, set this number to 3. And the only time this should increment, once I press this should increment to 4. Like it does right now. And like these components of half adders, which adds 2 bits, with the half adders, which adds 2 bits together, which I'll show in a little bit. I'll show in a little bit how this half adder works, which helps make this incrementer work. And if we pull up the GTK wave for the incrementer circuit, if you pull up the waves for that, obviously as shown for the behavior, A3 is the input, Y3 is the output, and the increment is always on. While the incrementer is on, it increments the value by 1, 0, 1, 1, 2, 2, 3, and vice versa. And now to move on to the half adder. This half adder adds 2 bits. 0 plus 0 equals 0. 1 plus 0 should equals 1, as seen with the sum here. 0 plus 1 so equals 1 here, but if we add 1 plus 1, we get 2, which is the equivalent of 1, 0, with the carry being the bit in the upmost front bit, and the sum being the back bit. We can do a quick waveform of this one also, to show the half adder, which shows how the incrementer works. So the half adder. So with this half adder, this shows the exact behavior I'm talking about, with the only time the carry bit is 1 when both of these are 1, else the carry bit should be 0, and the only time the some bit is 1 is where it's where either A and B are both different values, as shown with the circuit and the waveform. And now for the final circuit to show is the 4-bit adder. This is the 4-bit adder, which works by adding 4 bits. For example, if I do 2 plus 2, it outputs 4, and we're gonna quickly show off the waveforms for the 4-bit adder. As seen here, y is a plus b. 1 plus 1 equals 2. 2 plus 2 equals 4. 3 plus 3 equals 6. This proves that the circuit is working as intended, just fine. So we don't need to worry about that. And that is my video for Lab 1, and my name is Christopher Lewis Saint.